Hello everyone. In today's class, I will be discussing about the origin of microprocessors, that is the evolution of microprocessors. The microprocessor is the greatest invention of the 20th century. Its evolution started from the earlier mechanical calculating devices in the 1930s. These devices used mechanical relays. Later in the 1950s, these devices were replaced by vacuum tubes. The vacuum tubes were quickly replaced by transistors. The breakthrough in transistor technology led to the introduction of mini computers in the 1960s and the personal computer revolution in the 1970s. The transistor technology led to the development of complex devices called integrated circuits. The microprocessor or microprocessing unit later evolved as an IC and was designed to fetch instructions and execute the predefined arithmetic and logic functions. Intel was the first microprocessor producer and has been holding a large share of the world market for this product. The evolution of microprocessors is categorized into 5 generations: first, second, third, fourth, and fifth. So, moving ahead with the first generation, the microprocessors that were introduced from 1971 to 1973 were referred to as the first generation systems. First generation microprocessors processed their instructions serially. They fetched the instructions, decoded it, and then executed it. The first microprocessor, the 4004, was introduced in 1971. It was co-developed by Busicom, a Japanese manufacturer of calculators, and Intel, a US manufacturer of semiconductors. The 4-bit 4004 microprocessors ran at 108 kHz and contained 2300 transistors. They were fabricated using P-channel metal oxide semiconductor technology, which provided low cost, low speed, and low output currents. They were not compatible with transistor logic. In 1972, Intel made the 8-bit 8008 and 8080 microprocessors. So in the second generation, as technology evolved, the number of circuits that could be fabricated on a chip grew. Very large scale integration led to the chips that had speeds up to hundreds of millions of switchings per second. The second generation marked the beginning of very efficient 8-bit microprocessors. Some of the popular processors were Motorola's 6800 and 6809, Intel's 8085, and Zilog's Z80. The second generation devices marked a sharp contrast with the use of newer semiconductor technology to fabricate chips. They were manufactured using N-channel metal oxide semiconductor technology. This technology offered faster speed and higher density than PMOS. It resulted in a 5-fold increase in instruction execution speed and higher chip densities. So the third generation introduced in 1978 was dominated by Intel's 8086 and Zilog's Z8000, which were 16-bit processors with mini-computer-like performance. These processors had the technology of 16-bit arithmetic and pipelined instruction processing. The third generation came with IC transistor counts of about 250,000. In Motorola's MC68020, for example, an on-chip cache was incorporated for the first time and the depth of the pipeline was increased to 5 or more stages. It was designed using high-density metal oxide semiconductor technology, that is HMOS. HMOS provides some advantages over NMOS. Its speed power product is 4 times better than that of NMOS, and it can accommodate twice the circuit density of NMOS. So the next generation is the fourth generation. The microprocessors entered their fourth generation with designs containing more than 1 million transistors in a single package. This era marked the beginning of 32-bit microprocessors. Intel introduced 80386 and Motorola introduced 68020 or 68030. They were fabricated using high density, high speed, complementary metal oxide semiconductor, that is HCMOS, a low power version of the HMOS technology. And the next generation is the fifth generation. The fifth generation microprocessors employ decoupled superscalar processing, and their design contains more than 10 million transistors. This generation marks the introduction of devices that carry on-chip functionalities. It has also paved the way for high-speed memory input-output devices, along with the introduction of 64-bit microprocessors. Intel leads the show here with Pentium, Celeron, and very recently dual and quad-core processors working with up to 3.5 GHz speed. This generation is characterized by a low margin single microprocessor PC business, which is complemented by high volume sales. So in the next slide, I have shown the timeline of microprocessor evolution, that is in which year which microprocessor came along with the number of transistors it used and the speed of that particular microprocessor. So in 1971, Intel 4004 microprocessor came with 2300 transistors working at a speed of 108 kilohertz. In 1972, Intel 8008 came twice as powerful as the 4004 with 3500 transistors, and the speed was 200 kilohertz. Similarly, in the various years I have mentioned the microprocessors which came along with the speeds, along with the number of transistors they used. So we'll continue in the next class. I'm ending the class here.